Good morning, students. In earlier classes, we have discussed about the inverse Laplace transformations and the inverse Laplace transformations of some standard functions. Now, we will discuss about some properties of the inverse Laplace transform. The first property is the change of scale property. Change of scale property. Change of scale property for inverse Laplace transform. The statement of this property is if the inverse Laplace transformation of a function fp with respect to x is equals to f of x, then the inverse Laplace transformation of f of ap with respect to x is equals to 1 upon a f of x. The proof of this property is obtained by the definition of the inverse Laplace transformation, which shows that the inverse Laplace transformation of a function fp with respect to x is equals to f of x. Then, by the definition, fp is equals to Laplace transformation of f of x with respect to, and by the definition of the Laplace transformation of a function fx, this is equals to integral 0 to infinite e raised to minus dx fx dx. Now, if we replace p by ap in 1, then f of ap is equals to integral 0 to infinite e raised to minus p ap into x f of x dx, or this can be written as integral 0 to infinite e raised to minus p into ax fx dx. If here we put it ax is equals to t, then dx is equals to 1 upon a dt. Then second implies f of ap is equals to integral 0 to infinite e raised to minus pt f of t upon a dt upon, or the right hand side is equals to 1 upon a integral 0 to infinite e raised to minus pt f of t upon a dt, or we can write this one as 1 upon a integral 0 to infinite e raised to minus px f of x upon a dx. If we see the right hand side, the integral of the right hand side, we see that it is equals integral 0 to infinite e raised to minus px f of x upon a dx, which is the Laplace transformation of a function f of x upon a. So this is nothing but 1 upon a Laplace transformation of f of x upon a with respect to p, and we can write this one as 1 upon a f of the Laplace transformation of, this is this one. So we get here f of ap is equals to 1 upon a Laplace transformation of f of x upon a with respect to p, or we can write it as Laplace transformation of 1 upon a f of x upon a with respect to p. If we take the inverse Laplace transformation on the both the sides, we get, taking inverse Laplace transform on both sides, we get inverse Laplace transformation of f of ap with respect to x is equals to 1 upon a f of x upon a, which is the required change of scale property for the inverse Laplace transformation. Another property for the inverse Laplace transformation is the first shifting property. The statement of the first shifting property is, if the inverse Laplace transformation of a function fp with respect to x is equals to f of x, then f of inverse Laplace transformation of if inverse Laplace transformation of f of p is equals to fx, then inverse Laplace transformation of p minus f of p minus a, the inverse Laplace transformation of f of p minus a with respect to x is equals to e raised to ax f of x. The proof of this theorem again comes out from the definition of the inverse Laplace transformation, which shows that if the Laplace transformation of a function fx with respect to p is equals to fp, replace p by p minus a, we get f of p minus a is equal, first we write the first equation as, complete in integral form. Fp is equals to Laplace transformation of fx with respect to p is equals to integral 0 to infinite e raised to minus px f of x dx. Now replace p by p minus a, we get f of p minus a is equals to integral 0 to infinite e raised to minus p minus a into x f of x dx. Now solving this, we get this one as integral 0 to infinite e raised to minus px into e raised to ax fx dx. Now on the right hand side we see that this is the Laplace transformation of the function e raised to ax fx. So this is the Laplace transformation of the function e raised to fx with respect to p. Inverting both the sides or taking the inverse Laplace transformation, both sides, we get inverse Laplace transformation of f p minus a with respect to x is equals to e raised to ax f of x, which is the required first shifting property. So we have discussed about some properties of the inverse Laplace transformation. In next class we will discuss some more properties of inverse Laplace transformations. Thank you very much.